Hello. So I got a request to show how to conduct an independent samples t-test on data that is in wide format in R. So when your data is in wide format, what that really means is the values you want to compare, rather than being stacked in the same column, are spread out across multiple columns. So for example, here is data from a hypothetical experiment, okay? Let's imagine that it's a very simple cognitive memory study. So we have ID numbers for individuals in the first condition, the biological sex of individuals in the first condition, and the number of words they've recalled, like as if the participants were presented with a list of words, asked to study them a particular way, and then were given a recall test. How many words can you remember? Please write them all down. Then here we are, the second condition, the ID numbers for their subjects, the biological sex, and the number of words that they recalled. So what you can see is really our dependent variable is words recalled, but it is distributed across two different columns. And we want to compare these columns. Now, one way to do it, and it's probably the better way to do it, would be to convert that into long format. However, for the purpose of this video, I'm just going to show you how to do it when it would actually be in wide format. So, when you have data like this, it's actually really simple to do the t-test. T.test, it's the same function as when it's in long format, but instead of specifying the dependent variable using a tilde and then specifying the independent variable, we really just specify the two columns we want to be compared. So conditions merged is the name of my data frame. A $sign, so now I'm specifying the particular column. Words recalled 1, comma. Then my second argument is the second piece of data that I want to compare. $sign words recalled 2. Then, and I'm actually going to break this across lines so that it's easier to read, specify whether we want the t-test to assume equal variances. Now, the default in R is false. However, typically people always assume this. It's an assumption that's usually met, and it doesn't really become problematic until there's a very large deviation. So we can go ahead and just assume true, and then it's a simple matter of running your code. So we have a 2-sample t-test in this case. Here is the data that is being compared. So it's running a t-test on data in this column compared to this column, and it's an independent samples t-test. Our t-value 11.6 and change, degrees of freedom of 76, and then our p-value here is 2.2 times 10 to the negative 16th. So we're well below most standard alpha levels, be it 0.05 or 0.01, and so we would have a significant difference here in this case. Now, to do a t-test in this fashion, it doesn't even need to be in the same data frame. For example, perhaps the data from this experiment was actually given in 2 different Excel files, one for condition 1 that just has the ID numbers, the biological sex, and the words recalled, and a separate one for condition 2 that has the ID numbers, the sex, and the words recalled. Now, you can run this t-test essentially just the same as well, where we specify we want condition 1, we want the words recalled column, and we want to compare that to condition 2, and we want the words recalled column. We want equal variances to be assumed. You can see here's the results from that t-test, and it exactly matches up here. Now you could do this on data that's not even in a data frame as well. So let's say X is a random normal distribution R norm, this generates a random normal distribution of 100 scores with a mean of 100 and a standard deviation of 15. And Y is another R norm with 100 scores, a mean of 115, and standard deviation of 15. Okay, so we could do a t-test comparing X and Y, assume variances are equal, and then we have the t-test for that. So that's how you would conduct a t-test in wide format or just a simple between subjects t-test on two different R elements, or R objects, excuse me. I hope this helps, and good luck.